Hi, fourth graders. This is your science intro video for this week. Unit 4, Waves and Information, Lesson 4, Which Waves Travel Through Earth? So I want you to take a few seconds and look at this picture of this house. Think about what could have caused the house to be in such disarray. Could it have been a tornado, a hurricane, or even perhaps an earthquake? If you're thinking an earthquake, you're correct. So this week, we're going to learn and read more about the types of waves that cause earthquakes. So, what is an earthquake? An earthquake is a shaking of the ground caused by sudden movement of the Earth's crust. So, the Earth's crust is an outside layer of the Earth. So, the Earth, think about it as a sphere, and inside there's different layers. On the very outside, where we live, is the crust. All right, seismic waves. Seismic waves are different types of waves. There's 3 of them that cause earthquakes. So the 3 types of seismic waves are P waves, primary waves, S waves, secondary waves, and surface waves. All earthquakes have these seismic waves, and they also get weaker as they spread out across the earth. So here are some pictures and diagrams of seismic waves. You can see that they start in the center and kind of move out. So let's dive deeper into what are these 3 types of seismic waves. P waves, primary waves. This is the first type of seismic waves, so it happens first during an earthquake. It's the fastest. It can travel through all kinds of matter. So what does that mean? So if here's my P wave and it's traveling outward, look, it goes through the Earth's crust. It goes through different layers beneath the Earth's crust. It goes through liquid also. So if there's lakes or oceans, it can travel through that. It can also travel through air. So here's just a quick diagram of the layers of the Earth. So P waves can travel all through this. They can penetrate it, which is pretty cool. They're also the most similar to sound waves that we learned about last week. S waves, secondary waves. This is the second type of seismic wave. They're slower than P waves, but they cause more damage than P waves. They cannot travel through air, liquid, or the Earth's inner core, which is really, really hot. It can't travel through that. These S waves are most similar to waves on a string because they move side to side. And if you take a look at our diagram here, they're traveling outward just like P waves, but notice it cannot penetrate or go through liquid. So something different than P waves. All right, the third type is surface waves. Surface waves happen on the Earth's crust, so the surface. It's the slowest seismic wave. However, it's the last to arrive during an earthquake. And when we feel shaking during an earthquake, it's caused by these surface waves. So these surface waves can be pretty damaging. It can cause buildings to fall. It can cause cracks in roads. All of those things are due to surface waves. They travel on the surface only, and they're similar to water waves that we learned about last week because they make the ground roll in small circles. So if you notice here in our diagram, it shows these waves are only on top, only on the surface, and then they stop when they hit other properties. All right, so who studies earthquakes and these types of waves? What types of scientists and engineers? These types of scientists and engineers are called seismologists. So it's in the field of seismology. It's a type of geology that studies the layers of the earth, and they use seismographs. So these types of machines that help them measure and detect the seismic waves happening in the earth and ultimately when an earthquake is happening. So pretty cool. There's specific types of scientists that study this every day, 24 hours a day, all over the world. All right, fourth grade scientists or seismologists, I hope you have a great week learning more about which waves travel through the earth.